All right, welcome to another series of special functions, and today we'll be looking at the problem on beta function. And it says that you should show that the integral from 0 to infinity of t raised to power n minus 1 all over 1 plus t raised to power n plus n dt is equal to the beta function of n comma n, where your m and n they are greater than what? 0. So we know that by definition, right? By definition, the beta function of n comma n is given by the integral from 0 to 1 of t raised to power n minus 1 times 1 minus t raised to power n minus n dt, where your m and n is greater than what? 0. Alright, so we can solve this. We are trying to express this in form of this given equation here. Alright, so how can we do it? Now, don't forget that they have different limits. So one of the things we're going to do is just to change the limit from 0 to 1. Exactly. So we can do this by substitution. So let t be equal to 1 over 1 plus x. Alright, so 1 over 1 plus x. So now, in this place, we can say that this is also the same as t equal to 1 plus x, all raised to power minus 1. So if we differentiate this with respect to x, we'll be having minus 1 raised to power 1 plus x raised to power minus 2. So which means that the t is equal to minus 1 plus x raised to power minus 2 dx. Alright, so we can also write it like this: dt equal to minus 1 over 1 plus x raised to power 2 dx. Alright, now don't forget, we can let us change limits. So change of limits. Now we know that t is equal to 1 over 1 plus x. So making x the square root of formula, we can write it as 1 plus x is equal to 1 over t. Yes? Alright, which means that x is equal to 1 over t minus 1. So you have our equation now. So when t is equal to 0, alright? So when t is equal to 0, x is equal to 1 over 0 minus 1. So we can 1 over 0 is on the bar, we can still say it's what? Tending to infinity, x equal to infinity. So when t is equal to 1, alright, when t is equal to 1, x is equal to 1 over 1 minus 1. So which means that x is equal to 0. Alright, so we can write this function here, that is the beta function of n comma n is equal to the integral from, now don't forget we have changed our limit. When t is 0, alright, x is infinity, and when t is 1, x is 0. So from infinity to 0 of t. Now don't forget that we have changed t to this. So that's going to be 1 over 1 plus x, right, all raised to power n minus 1 times, we have 1 minus, this is t, which is same as 1 over 1 plus x, all raised to power n minus 1. Then dt, now don't forget that dt is equal to this. That's going to be negative dx over 1 plus x raised to power 2. Alright, now looking at this, when we simplify, we can have it that of n comma n is equal to the integral, alright, the integral from from infinity to 0 of 1 over 1 plus x all raised to power n minus 1. Yes, because we can bring this down, we can separate them, alright, times. Now if we look at this, alright, if we find the LCM of this middle term here as 1 plus x, alright, so 1 here is what? 1 as 1 plus x minus 1 plus x is 1 plus x is 1 times 1 is 1. So this will give us what? This will give us x over 1 plus x. So instead of writing this whole thing, we can write it as, I know that it is all squared, right? N minus 1. So we can write it as x raised to power n minus 1 over 1 plus x raised to power n minus 1. So we can write it like this, x raised to power n minus 1, right? Over 1 plus x raised to power n minus 1 times the last term is we have, don't forget there's a negative in this place, all right? So we have this dx, negative dx over 1 plus x raised to power 2. Now don't forget that you know that when you have the integral from a to b of negative dx, alright, it is the same as saying the integral from b to a dx. Alright, so look at it. We have negative here. So if you want to change the limit, if you want to cancel out this sign, you have to change the limit. So looking at it now, we can write this as the beta function of n comma n to be equal to the integral from, now cancelling this negative sign means we have to change this limit from 0 to infinity of 1 over 1 plus x raised to power n minus 1 times x raised to power n minus 1 over 1 plus x raised to power n minus 1 dx over 1 plus x raised to power 2. So we are getting there already. So now we can see something in this place, right? Let us try to look at this denominator. They are the same. So now from the law of indices, we know that we have a raised to power n times a raised to power n. When they have the same base, all you just need to do is add the power. Alright, so this becomes beta function of n comma n to be equal to the integral of 0 to infinity of, now you have x raised to power n minus 1 all over, now they are of the same base, that's going to be 1 plus x raised to power n minus 1 plus n minus 1 plus what? Plus 2, exactly, dx. Alright, and this gives us what? The integral from 0 to infinity of x raised to power n minus 1 over 1 plus x raised to power, now minus 1 plus 2 give us 0, so we are left with n plus n dx. Alright, so we can see that we are already getting there. Now, okay, let me write it out. We have beta function of n comma n to be equal to the integral of 0 to infinity of x raised to power n minus 1 over 1 plus x raised to power n plus n dx. But if you look at this and the real equation, you see that our variable here is t instead of x. But you know that from the property of definite integral, you know that when we have the integral of a to b of f of x dx the same as what the integral from a to b of f of y dy, which means that you can simply change the variable given that you are changing this dx. That is, if you don't change this to dt, so if you don't change the x to t, so this one will also change to what dt. So which means that the beta function of n comma n is equal to the integral from 0 to infinity of, instead of x, let's write t raised to power n, right? T raised to power n, t raised to power n minus 1 over 1 plus t raised to power n minus plus n dt. Now, don't forget that the beta function of n comma n is same as what? The beta function of what? Of n comma n, alright? So this is called the symmetric property. Yes, symmetric property of beta function. Exactly. So which means that this is same as the integral from 0 to infinity of t raised to power n minus 1 over 1 plus t raised to power n plus n dt. Proved. So you can see that we're having the same results as this. Don't forget to always put a condition where n comma n is greater than 0. So please like and share this video.